Okay, so opposite angle identity that hopefully everybody knows because we did them on the quiz this morning. Cosine of negative x is just cosine of x. Sine of negative x is negative sine x. What happens with this double negative right here? Makes it positive. So cosine x plus sine x, which of course equals the other side. Alright, let's see what I want to do next. Let's do number 47. So for 47, we have cotangent x minus cosecant x times cosine x plus 1 equals sine x. So there's a few options on, yes. Oh, okay, yes, right here, sorry, thank you. All right, so there's a few options on how you can deal with this here. We could change everything to sine and cosine from the very beginning and see what happens. What I would probably do for this is I would go ahead and distribute before you change the sines and cosines. So you would have cotangent x times cosine x. Then we'd multiply our outers. We just have plus cotangent x. Our inside terms, we're going to get minus cosecant x cosine x. And for our last term, we would just get a minus cosecant x. This kind of made it look worse. My hope, though, was maybe that when I change things to sine and cosine, they'll cancel. I'm not sure if they will, but we'll see. So we got cotangent is cosine x over sine x. And that'll be multiplied by cosine x plus cosine x over sine x minus 1 over sine x times cosine x minus 1 over sine x. And so where I have this like cosine x over sine x times cosine x, that cosine x is like a cosine x over 1. Same thing over here. This is like a cosine x over 1. So if I multiply these together, I'm going to get cosine squared x over sine x. And I'll have plus cosine x over sine x. Minus, when I multiply this together, I get cosine x over sine x. And then I've got 1 over sine x. So, questions so far? Does anybody see something that can happen here? What can happen, Josie? These middle two are going to cancel each other out. And so Also, since everything has a denominator of sine x, I can put these together with the same denominator. So I'll have cosine squared x minus 1 over sine x. Not quite. I know that sine squared x equals 1 minus cosine squared x, not cosine squared x minus 1. So it's close, but not quite. But I do know that my answer over here does not have a denominator. So somehow I got to cancel this sine with something, right? And I can't cancel it with something that has a cosine. So what do you think, Bo? Okay, so let's try that. Let's change our cosine squared x to 1 minus sine squared x. And then we'll still have this minus 1 over here, right? And so now this positive 1 right here and this minus 1 right here, they're going to cancel each other out. So I'm going to have negative sine squared x over sine x. And what will happen with one of those signs? They will cancel, and we'll just be left with negative sine x, which is what we had on the other side. Questions? Let's see, I want to do one more together. Which one do I want to do? Let's do 43. Okay, what do you guys think? I would do left side. What can we do on that left side? Change the secants, because in general, secants and tangents and cosecants are going to give us trouble. So we'll have 1 over cosine t minus cosine t over 1 over cosine t. Draw me some lines here. Things get confusing whenever we've got complex fractions. Alright, what can we do now? What do you think, Matthew? Good. So right now that cosine t right there is over 1. What are we going to have to multiply by? And so when we do that, we'll get 1 minus cosine t. Perfect. And then don't lose that denominator. It's over 1 over cosine t. Now I've got everything as fractions. So once I've got everything, one fraction on top and one fraction on bottom, what can I do? Well, flip and multiply. So I have 1 minus cosine squared t over cosine t times cosine t over 1. I see a cosine on top and bottom here. Can these two right here cancel? Yes, because see what's separating them? Multiplication, right? You can't cancel with this cosine t because it's separated by a minus sign from that 1. But here we're multiplying, so it's fine to cancel that. So we get 1 minus cosine squared t over 1, which we don't have to write. And what is 1 minus cosine squared t? Sine squared t, which is what the other side was as well. Okay, questions? Okay, so the absolute best thing to do to practice this is just do lots of these problems, right? I'm going to assign some of them as homework, but really anything on 29 through, really 29 through 90 would be okay. I don't see anything there that I absolutely wouldn't give you. I wouldn't give you 85. If you guys do a different cubes there. If you see a cube, it will look like the one from last night's homework. It will not look like number 85 because you would have to know how to factor a difference of cubes for that, which we haven't done. So, I could give you 4. I won't give you anything over 4. Like if you look at number 48, sine to the 4th theta minus cosine to the 4th theta, and it's supposed to equal sine squared theta minus cosine squared theta. This one's actually a really easy one if you know what to do with those 4th powers. So when we factor, we could factor that stuff to the 4th power. We could put a sine squared here and a sine squared here. And then we could do plus cosine squared and minus cosine squared. Right? It's a difference of squares, but since it's to the 4th power, you're going to have squares right here instead of just sines and cosines. And what is sine squared plus cosine squared? It's just 1. So you just get sine squared theta minus cosine squared theta. So I wouldn't rule out that I might give you something like that, but you're more likely to just see squares. So, I'm going to assign for homework number 41. Actually, let me back up. I'm going to give you one for that. I'm going to give you number 30, 31, 41. Let's see, let's go over here and do 55. $64. do 75 and 90. So these are the ones that are required. But if you just want extra practice, lots of these are good for you to do. They're good problems. So I wouldn't spend a lot of time on ones with fourth power. Number 85, I know for sure I won't give to you. But really, most of these are good practice problems. So you got about 15 minutes here. Go ahead and start on those.